The curve C1 has equation y equals minus a over x, where a is a positive constant. The curve C2 has the equation y equals x minus b all squared, where b is a positive constant. Part A. Sketch C1 and C2 on the same set of axes. Label any points where either curve meets the coordinate axes, giving your coordinates in terms of A and B. So let me draw a set of axes here. Here's my x-axis. Here's my y-axis. Right, let's focus on the curve C1 first. We've got y equals minus a over x. So I know that's the 1 over x graph. Let's start with thinking about that. I know that usually looks something like this, where we have asymptotes. We've got an x asymptote of x equals 0, and we've got the horizontal asymptote, which is y equals 0. I know that the timesing by the a, if I put an a on top there, all that will do is just scale it a little bit. So it might look a bit more like this, for example. Or it might look a bit more like this, for example. But it's still going to have the same shape. And unless I put a scale on my y-axis, it doesn't really matter. However, we don't have an a on the top here. We've got a minus a. And what that minus does is just flip these around. So actually it's going to be looking more like this. In these quadrants. So there we go. That is my graph for the C1. Now let's move to C2. So we've got the y equals x minus b all squared. So it's quadratic. It's a positive quadratic because if I expanded this out, I'd have a plus x squared and not a minus x squared. So therefore I know it's a U shape rather than an N shape. I can also see that it has a repeated root when x equals b. This will equal 0, the y coordinate will equal 0 when x is b. And that's a repeated root because of the squared here. So b is a positive constant, so on my graph I'm going to put b, I don't know, here maybe. As long as it's positive, it doesn't really matter. And the fact that it's a repeated root means it's going to just touch that point and then come back up again. The only other coordinate I need to mark on here is the intercept on the y-axis here. That's going to be when x equals 0. So if I put 0 in here, I get y equals 0 minus b. So minus b squared, which is b squared. And there we go. So I've drawn C1 and C2 onto my graph. Let me just label them up. So this is the y equals minus a over x. And this red line is the y equals a minus b all squared. And I've marked on the key intercepts and the asymptotes. The question didn't ask me to mark on the asymptotes, but it's always a good idea to draw them on. Most of the time they will ask you to do that. Right, part B. Using your sketch, states the number of real solutions to the equation x times x minus 5 all squared plus 7 equals 0. The question says using your sketch. So I'm thinking, what has this got to do with what I've just drawn? What's this got to do with these two equations? Well, if I do a little bit of rearranging here, so if I subtract the 7 from both sides, and then I divide both sides by x, I notice that actually this is very similar to my C. Let me colour code this to make it clearer. This is very similar to the C2 curve. And this is very similar to my C1 curve. We can just see that here, this is like B being 5 in my x minus b. And this is very similar to just A being 7 in my C1 curve. So actually, this equation here, all it's saying is, when do my curves intersect? When does my C2 equal my C1? The question doesn't ask me to work out the solutions, it just asks me to state the number of solutions. So looking at my graph, how many times do the graphs intersect? Once. There is one solution. So there is one solution because the sketch shows the graphs will intersect in one place.